last time we left off, and we had talked a little bit about how the models of the atom had progressed from Dalton's model of the solid chunk all the way through Rutherford's model of the nucleus in the center and the electrons around the outside. Okay, more scientists did more experiments, and we learned a little bit more about the atom. Okay, and we know the atoms, all atoms, are made of three parts. Okay, so atoms contain three subatomic particles, they're called. Subatomic means smaller than atoms. So atoms are composed of these subatomic particles, these little particles that make them up, and they all contain the same three. It's just how many of them that are in there that changes the atom. Atoms are composed of subatomic particles, and they are the proton, which is positive, okay, the neutron, which is entirely neutral. That means it has no charge at all. It's not positive, it is not negative, it has no charge. I want you to remember that. Neutral neutrons are neutral. Neutral neutrons have no charge. People will tell me that neutrons are negative, but neutrons are not negative. Neutral neutrons are neutral. Neutral neutrons have no charge. The particle that's negative, remember, was the one discovered by Thomson, and it's called the electron, and it has a negative charge. Okay? Now, these particles are not at all in any way the same. Okay? There's some similarities between them, but they're different. Okay? So these two guys, the protons and the neutrons, they hang out together in the middle of the atom. They make up the nucleus. Okay? So protons and neutrons are similar in size. They have about the same mass. Okay? Close enough that in this class we don't have to care about the difference. Protons and neutrons have almost the same mass. They're about the same size, and they make up the nucleus. Okay? The nucleus, remember, is the center of the atom. Okay? That's the thing that Rutherford discovered, and so it's the tiny, dense center of the atom. The nucleus is the tiny, dense center. Okay? Now, that's going to leave the nucleus positive. It's got positive protons in it and neutral neutrons, and so I have a whole bunch of positive charge, but no negative charge. But atoms are neutral, and that's where the electrons come in. The electrons orbit the nucleus. They're found in the space around it. Okay? And there's always the same number of electrons and protons. Electrons balance the charge of the neutrons, or not the neutrons, electrons balance the charge of the protons, and that makes the atom neutral. Okay? So remember that. Atoms are neutral. They have the same number of protons and electrons. The protons are positive, the electrons are negative. That makes the whole atom neutral. Okay? So we've got this down. We've got three particles in the atom, the protons, the neutrons, and the electrons. The protons and neutrons are in the middle in the nucleus, and the electrons go around the outside. Okay? What we want to spend a little bit more time on is the nucleus, because the nucleus determines everything there is to know about what this atom is. Okay? And so everything that we're going to do as far as identifying elements, as far as knowing how many electrons something has or where to put it on the periodic table, comes from the nucleus. Okay? And this is a big deal. The protons, okay? Because the protons are positive and they attract the electrons, they're the ones that determine what the element is. The protons determine the element. Okay? And because the protons are so important, okay, they get their own special name. Atoms of different elements have different numbers of protons. Okay? And that's basically the big distinguisher. Atoms of different elements have different numbers of protons. And so the number of protons is very, very important. It's so important that, like I said, we give it its own name. The number of protons in an atom, okay, is called atomic number. Okay, think about that. Atomic number. The atom is determined by the number of protons. The number of protons is the atomic number. Okay, so atomic number, number of protons, this is how we identify elements. Okay, so if you look at a periodic table of the elements, most periodic tables have some information written in them. Okay, well, all periodic tables have information written in them. Most have the same information in them. They're going to have a number up here, say like a 6 or something. Then they're going to have a big letter. Okay, sometimes they have a name, sometimes they don't. And then down here, they're going to have another number. Okay, and it's usually a decimal. Some of this information we care about, some of this information not so much. Okay, this 6 right here, we definitely care about that. That is the atomic number. Okay, that is the number of protons. Okay, this one, that's a big deal. This is the name or the symbol of the element. Usually we get both. Okay, this number down here, we're not going to talk about that number. We don't really care about that number. We might talk about it later, but for now we're going to ignore it. We don't really care what that number's about yet. Okay, so atomic number is the number of protons, and the symbol on there, and so those two things go together. If I'm talking about the element C, carbon, I'm always talking about an atom with 6 protons. If I'm talking about an atom with 7 protons, I'm not talking about this element. Okay, you'd have to look at a periodic table and find element number 7, and then you would know I was talking about nitrogen. So atomic number is the number of protons. Okay? But atoms don't just have protons. Atoms also contain neutrons. Okay? And the nucleus contains those neutrons. Atoms have neutrons as well, and these are also in the nucleus. And so it turns out the neutrons actually help hold the nucleus together. Okay? The neutrons hold the nucleus together, or help, because all those positive charges, they don't really want to hang out together. Positive charge repels other positive charge, and so the neutrons act as a balancer, really. They help make the nucleus stable. So the neutrons help hold the nucleus together. But that means we're adding mass to the center of the atom. We're adding mass to the nucleus. Okay? So the neutrons contribute mass. And because they do that, we have to know kind of a little bit about the neutrons, how many of them are in there. But since they're not affecting the charge, they don't attract electrons, they don't really change a whole bunch of properties about the atom, okay, the number of neutrons can vary. It's not like the number of protons. And so vary means change. And so this means multiple atoms of, say, titanium. Titanium's element number 22. So all atoms of titanium have 22 protons. They don't all have the same number of neutrons. There might be 21 neutrons, there might be 25 neutrons. It doesn't really matter. Okay? So the number of neutrons can vary within an element, which means we have to be specific when we talk about these things. So titanium, well, actually let's do this a different way. Okay? We have to be specific when we talk about these, and so we do that with numbers. But since the neutrons are not super duper important by themselves, the mass number doesn't just tell me the number of neutrons, it's the number of neutrons plus protons. Okay? And so there's two major numbers that can describe the nucleus. There's the mass number, which is the neutrons and protons together, and then there's also the atomic number, which is the number of protons. Now, atomic number is the big one. Atomic number is the number of protons. It determines the element. Mass number is what we use to identify specific isotopes. Okay, and all atoms are isotopes, but we have to be able to distinguish them. And an isotope are just atoms of a given element that have different numbers of neutrons. Okay, and so I was talking about titanium earlier. There's this thing called titanium 24. Okay, but there's also, wow, that's super messy, titanium 25, and there's also titanium 23. Okay, what's the difference between titanium 24, 25, and 23? What's the similarities between all of these things? Well, really, what we need to know is about the nucleus. The nucleus determines most of the things we want to know about an atom. Okay, and so titanium 24, this number right here in all these columns, this is the mass number. It's not telling me, ooh, and these shouldn't be 24s. Yuck. These, I should have looked at my table. 44. okay, 45, 43, okay. These are mass numbers, okay, and they're telling me the combined number of neutrons and protons. But sometimes I just want to know protons, sometimes I just want to know neutrons, okay? Well, if I want to know anything about titanium, I have to look it up on the periodic table. Okay, so titanium is Ti, and its element number 22. Okay, so its box on the periodic table looks Ti, 22, and then down here there's a 45 point something, 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 47 even, 47.87, okay, titanium. That number I don't care about. This number I do. That's the atomic number. So I know every single one of these has the same number of protons. They're all titanium, so they're all 22. Titanium is element number 22. It has 22 protons. Okay. So what's the 44 and the 45 and the 43? Well, titanium 44 is telling me that there's 44 particles in the nucleus. 22 of them are protons, which leaves us with 22 to be neutrons, because 44 minus 22 is 22. Titanium 45 has 22 protons because it's titanium, but there's one extra thing in the nucleus, so it must be a neutron. Titanium 43 has 22 protons because it's titanium. If it didn't have 22 protons, it wouldn't be titanium. But there's one less. Okay, so there's only 21 neutrons in titanium. So mass number tells me the number of protons and neutrons together. Atomic number tells me protons, and I can get the neutrons by subtracting. Okay, so mass number, atomic number, they both describe the nucleus of an atom, but atomic number is the number of protons. Mass number is the number of total particles in the nucleus.